This is a continuation of Chapter 7. Today we're going to classify quadrilaterals in the coordinate plane. So our very first thing we're going to check is we're going to check to see if the quadrilateral is a parallelogram. So we're going to check the slopes of the lines, and if the slopes of opposite sides are the same or equal, then the lines are parallel. So our first check, is it a parallelogram? Yes, the opposite sides are parallel. We will move on. No, the opposite sides are not parallel. That actually brings us to, it's just a quadrilateral. And I'm actually going to amend this. It could either be a trapezoid or a kite. Also, okay? The difference between those is a trapezoid has one pair of parallel sides. Kite would have none, but it does have some congruent sides. We're really not going to look at kites as much. And if it doesn't have any parallel sides, we'll likely just call it a plane quadrilateral. So moving on from does it have parallel sides, now we're going to check if there's right angles. So to check if there are right angles, we're going to check if the consecutive sides are perpendicular. So we're checking if the slopes of the consecutive sides are opposite sine reciprocals. So then we're moving on, either yes, the consecutive sides are perpendicular, or no, the consecutive sides are not perpendicular. And no matter what our answer was, we are now checking to see if the sides are congruent. And congruency is formed by the distance formula. So we're going to check with the distance formula if all four sides are congruent or equal. These all say equal, so we'll use equal here. So if all four sides are equal and we knew that it had right angles, it's a square. If all four sides are not equal, but we knew it had right angles, it's a rectangle. If all four sides are equal and it didn't have right angles, it's a rhombus. If all four sides are not equal and it didn't have right angles, it's a parallelogram. So looking at this all at once, our first check is slopes. We're checking how many sides are parallel. If opposite sides are parallel, we move on. We check the consecutive sides are perpendicular. Depending on yes or no there, when we check our distance formula, we'll get one of these four shapes. So we are going to classify the quadrilateral still using the following information. So first, let's draw a picture to identify the opposite and consecutive sides. So if I am going to draw myself a quadrilateral, and I'm calling it STEL, STEL. So the opposite sides would be ST and EL, or LE. Also, SL and TE. Consecutive sides are going to be sides that touch each other, share a common point. So ST and SL. That would be ST and TE. That would be TE and EL. Let's get rid of that. TE and EL. And then finally, EL and SL. Right, they're the ones that touch. So knowing this, we should be able to create a table, or have a table created for us, to determine the most specific name. So my sides for ST, TE, EL, and SL. And if I look back at the opposite side, where ST is opposite LE, ST is opposite LE, and TE is opposite LS. So if I look at this, 4 and 4, my opposite sides are parallel here. 2 and 2, my opposite sides are parallel here. So I do know both pairs or two pairs of opposite sides are parallel. And that should be the first thing we look for. All right, so going back to our table, is it a parallelogram? Yes, the opposite sides are parallel. So the next thing we're going to check, are there right angles? So let's check the consecutive, one after the other, slopes. So 4 and 2, or 2 and 4, or 4 and 2, and 2 and 4 are those opposite sign reciprocals. And the answer to that one is no. So since it's no opposite sign reciprocals, means not perpendicular. So no right angles. So now in our chart, we went no. The consecutive sides are not perpendicular. We do not have right angles. So it can either be a rhombus or a parallelogram. So now we're checking to see if all sides are equal. And I look at my distances, 7, 7, 7, 7. I do see all sides equal or congruent, which means no right angles, but all sides were congruent. That brings us to rhombus. So the most specific name for this shape is a rhombus. All right, looking at the next example. So I'm looking at opposite sides, 3 and 3, 1/3 and a 1/3. Opposite sides are parallel, so we know we're going to move on. 3 and 1/3, not perpendicular, which means no right angles. My sides are not all the same, so all sides not congruent. So if we look at our chart, are there right angles? No. Are all sides congruent? No. It is a parallelogram. All right, example 3. 3/4 and 3/4, -4/3, -4/3. So we're opposite parallel. Consecutive sides, 3/4 and -4/3. We are perpendicular, which means there are right angles. If I look at all my distances, 11.5, 11.5, 11.5, 11.5, all sides congruent. So looking at our table, does it have right angles? Yes. Let's check all the sides. They're all the same. So that's a square. All right, one more together, and then there's 2 you could try on your own. So here I have 1/3 and 1/3, undefined and -4/3. So I only have one pair of parallel sides, which means it's not going to be a parallelogram or a rectangle or a rhombus or a square. This, because it has one pair of parallel sides, is a trapezoid. And then we're going to take it one step further. These would be my bases because they are congruent. Sorry, because they're parallel, which means these are the legs. So if I look at the distance of the legs, if they're the same, that made the trapezoid. These are the same. So I'm going to actually extend these here, right? Because my legs are congruent. All right, you're going to try the next 2. All right, pause. When you're ready to see the answer, hit play. All right, so in check-in 1, I only had one pair of opposite sides parallel, so it was a kind of trapezoid. Looking at the legs, they were not congruent, so this is just a trapezoid. In check-in number 2, I do have 2 pairs of parallel sides. The sides are perpendicular, so it has right angles, but all sides are not congruent. So this shape is a rectangle. What you'll likely have to do is make the table yourself. So if I'm going to make the table myself, if it's A, B, C, D, the way I'm going to write my sides are A, B, then I'm going to take that letter B and go to the next one C, then I'm going to take that letter C, go to the next one D, and then D would go right back to the beginning So I'm going to find the four slopes. So negative 2 minus negative 4 and 8 minus 9. So this is negative 2 plus 4 or 2, and 8 minus 9 is negative 1. All right, then we'll move on to the next one, B and C. Negative 5 minus negative 2, 2 minus 8. So negative 5 plus 2 is negative 3, 2 minus 8 is negative 6. This is really a positive 1. All right, the CD, negative 7 minus negative 5, 3 minus 2, negative 7 plus 5 is 2, sorry, negative 2, 3 minus 2 is 1, so it's negative 2 again, and then negative 4 minus negative 7, and 9 minus 3, that's negative 4 plus 7 is a positive 3, 9 minus 3 is positive 6, so that's 1 half. So looking at this, negative 2, negative 2, 1 half, 1 half, we do have two parallel sides. Negative 2 and positive 1 half, we have right angles. So we have sides are perpendicular, has right angles. So the distances, there's a little shortcut we could use for the distances. If you recall, the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We just did that work in the slope because up here was y sub 2 minus y sub 1, and down here was x sub 2 minus x sub 1. So these two numbers are what we get when we do these two things. So what I'm going to do is I'm going to take the distance formula, and I'm just going to take, instead of doing all the work, I'm going to put 2 squared plus negative 1 squared, and I'm going to work from here. So this is 4 plus 1, the square root of 5. The really important thing we have to do, though, is we have to use the original numbers before I reduce them, because the actual work of x2 minus x1 was negative 6. The actual work of y2 minus y1 was negative 3, not 1 and 2. So we have to use the original numbers. So we're going to have negative 3 squared and negative 6 squared. So that's going to be 9 plus 36. That's the square root of 45. And we're going to leave it like that. We won't even turn it into a decimal. We won't reduce it because all we're trying to do is see if they're the same. So square root of 45 is okay. So now we're going to do CD. That was negative 2 squared and positive 1 squared. So that's 4 plus 1 square root of 5. And then again, now we're using the 3 and the 6. 3 squared plus 6 squared is 9 plus 36. That's the square root of 45. So when I look at the distances, square root of 5, square root of 45, square root of 5, square root of 45, all sides not congruent. So our shape does have right angles, but all sides are not the same. So I would call this a rectangle. All right, are these the same numbers? 94, 802, 295. Oh, that's the same thing. All right, example 2. Let's classify quadrilateral QRST. So just like before, I'm going to start with Q and go to R, then start with R, S, S, T, and then T back to Q. So slopes, negative 5 minus negative 7. And 1 minus negative 2. So negative 5 plus 7 is 2. 1 plus 2 is 3. Negative 7 minus negative 5. 4 minus 1. Negative 7 plus 5 is negative 2. 4 minus 1 is 3. Negative 9 minus negative 7. 1 minus 4. It's negative 2 over negative 3, which is a positive 2/3. And then negative 7 minus negative 9, negative 2 minus 1. It's going to be a positive 2 over negative 3. So 2/3 and 2/3, negative 2/3 and negative 2/3. We do have two pairs of opposite sides are parallel. Looking at consecutive, 2/3 is negative 2/3. They're negatives, but they're not reciprocal. So not perpendicular means there's no right angles. So now we're going to take these numbers and put them into our distances. 2 squared plus 3 squared. 4 plus 9 is 13. Right, negative 2 squared and 3 squared. Another 4 plus 9, square root of 13. Negative 2 squared and negative 3 squared. Still positive 4, positive 9, 13. And 2 squared and negative 3 squared. 4 plus 9, square root of 13. So all sides are congruent, which means that I have no right angles, all sides congruent. This is a rhombus. All right, there's two check-ins here, so let's dual screen this for you. All right, go ahead, pause. When you're ready to see the answer, hit play. All right, so on check-in 1, I got slopes of positive 1, positive 8/3, positive 1, and positive 8/3. So I do have two pairs that are parallel, but they're not perpendicular, so there are no right angles. My distances came out to the square root of 18, square root of 73, square root of 18, and square root of 73, so all sides are not congruent. So that would be a parallelogram. In check-in number 2, my slopes were positive 1/5, negative 5, positive 1/5, and negative 5. So I did have two pairs of opposite sides parallel. And my consecutive sides are perpendicular, which means that it does have right angles. My distances, I got the square root of 26 for all four, so all sides are congruent. So right angles and all sides are congruent. That figure was a square. And that is the rest of chapter 7, classifying the coordinates, the quadrilaterals on the coordinate plane.